So hey everyone, so we have a question of increasing and decreasing function. So we have the function f of x sine to the power 4x plus cos to the power 4x, and the range of x that is acceptable is 0 to pi by 4, and both of them are included. The square brackets that we are providing, it means that both 0 and pi by 2 is included in the function. So how we can approach this question is that first we will find the first derivative of this given function, which is f of x, and then for the given range 0 to pi by 2 we will find the critical points at which the function derivative of the function becomes 0, and then analyze the increasing and decreasing nature with the first derivative of the function. So if we find f dash x, then it will be 4 sine cube x, 4 sine cube x, and differentiation of sine x is cos x. Then we have positive 4 cos cube x, and differentiation of cos x is minus sine x. So if you solve or simplify a little bit, then you will be observing that f of x, f dash x, is 4 sine cube x cos x minus 4 cos cube x sin x. Now take 4 sin x cos x common. After that we will be left with sin square x minus cos square x, and we have one identity that sin 2x is 2 sin x cos x, and cos 2x is cos square x minus sin square x. So we will be using these two identities in this equation to simplify it, because we have cos square x minus sin square x. If we take the negative sign common, then it will be simplified as minus cos 2x, and from here we can take out 2 sin x cos x, and from there we can get sin 2x. And sin 2x and cos 2x multiplied with one remaining 2 will give us sin 4x with an extra negative sign. So we will be having minus sin 4x. Alright, so this is f dash x. Now putting f dash x equal to 0, we will be getting this equal to 0. So 4x equal to n pi. Right? Why n pi? Because sin x, this sin x will be equal to 0 for x equal to n pi value. Like for if we put n is any given integer, so if we have n equal to 0, so x equal to 0, that sin 0 equal to 0. If we put n equal to 1, then x equal to pi, so sin pi is also 0. If we have n equal to 2, then sin 2 pi will be 0. So for any integer value of n, we will be getting sin x equal to 0. So similarly, sin 4x equal to 0 means 4x equal to n pi. So from here we will be getting x equal to n pi divided by 4. Right. So this is the value of x, possible values of x. Now we will be, these are the critical points. Since we have multiple critical points, but we will be considering only those critical points which fall in this range 0 to pi by 2. So first, after finding this critical point, we will be drawing the graph of this f dash x, that is sin 4x. So if we draw the graph of sin 4x, if we draw the graph of f of x, f dash x, that's minus sin 4x. If we draw the graph, then because we know that for sin 4x the graph will be simply like this, right? Simply it will be like this, positive, negative, right? But for minus sin 4x the graph will be reversed, so it will be like this, right? So we have negative, positive, and again here we have positive. Now what will be the critical values? It will be 0 here, and at this point we will be having n equal to 1. So for n equal to 1 we will be having x as pi by 4. So we have here pi by 4. Similarly here n equal to 2. So for that we have pi by 2, x equal to pi by 2, and similarly going forward. So we have to consider this range only 0 to pi by 2. So if you draw it on the wavy curve like 0 to pi by 2, and in between value we have 1 pi by 4, right? So from here we have here, and from here we go here, right? So before pi by 2 it's negative, then positive, then negative, then positive. So if we analyze the increasing nature, the increasing nature of this function sin 4x plus cos 4x will be between pi by 4 and pi by 2. So for x belonging to pi by 4 to pi by 2 close bracket, we will be getting the increasing nature. Since it's positive here, and for decreasing nature we will have 0 to pi by 4. So for x belonging to 0 to pi by 4, we will be having the decreasing nature. Thank you.